Hi guys, I hope you are all doing well. Let's see today's question. So today's question is based on the concept of ellipse and hyperbola. The question says E1 and E2 are the eccentricities of, so this is the eccentricity of an ellipse and that is given by x square by 18 plus y square by 4 equals to 1. And E2 is the eccentricity of a hyperbola that is given by the formula x squared by 9 minus y squared by 4 equals to 1. So this is an ellipse and this is an hyperbola given to us. E1 and E2 are the eccentricities as given. And further it says when E1 and E2 if are the coordinates on the ellipse that is given as 15x square plus 3y square equals k, we need to find the value of this k, right? So whatever eccentricities we get for this ellipse as well as this hyperbola, we'll substitute this as the coordinates x and y of the ellipse and we will get the value of k, right? So let's start with the question now. We'll understand the solution for this. Now if I compare the first ellipse x square by 18 plus y square by 4, that's equal to 1, right? So if I compare this ellipse with the standard form of the ellipse, x square by a square plus y square by b square equals 1, what I get here is a square is 18, b square is 4, right? A square is 18 and b square is 4. If I want to calculate the eccentricity for this, E1, that is nothing but c upon a, where c is the length or distance from the center to the foci. So E is equal to c by a, and c also, if you know, it is root of a square minus b square since a is greater than b, dividing by the length of semi-major axis a. Now if I further solve it, I can write it as root of a square minus b square upon a square, or I can also write it as root of 1 minus b square by a square. So that gives me root of 1 minus b square is 4, a square is 18, that gives me root of 14 by 18 or root 7 by. So this is root 7 by 9, which is the eccentricity E1. Let's calculate the eccentricity for the hyperbola as well. So the hyperbola's equation is x square by 9 minus y square by 4 equals 1. So if I solve that as well, hyperbola given is x square by 9 minus y square by 4 equals 1. If I again compare this with x square by a square minus y square by b square equals 1, a square here is 9, b square here is 4, right? So if I want to calculate the eccentricity again now the eccentricity is given by root of a square plus b square upon a for the hyperbola. I can also write this as a square plus b square upon a square, or I can also write it as root of 1 plus b square by a square. So that gives me b square is 4, a square is 9, that is 9 plus 4, 13. So I get the eccentricities in both the cases, E1 and E2. Now when I have both of them, I know E1 is root of 7 by 9 and E2 was root of 13. Right? So further, if I solve this, I can put the values of x as root 7 by 9 in this and y as root of 13 by 9 in this expression of the ellipse to get k. So if I just substitute, because it will satisfy since they are the coordinates lying on the ellipse. So 15 x square, if you see root sign gets deducted, so it remains 7 by 9 plus 3 y square, if you see it is 13 by 9 equals k. So k becomes 15 into 7 is 105, 13 into 3 is 39, dividing by 9, so it is 144 by 9, and that is 9 ones, so 54, 9, 6. So 60. So the value of k that will satisfy here in the ellipse equation is 16. And if you see the options, the option which matches with the answer here is C. So C is the answer for this question asked. I hope you have understood. This was a pretty easy question wherein you just need to know the formulas for eccentricities of ellipse as well as hyperbola, wherein the formula for ellipse is root of a square minus b square by a, and for the hyperbola it is root of a square plus b square by a. And once you get the eccentricities, you just need to plug in the values in the equation of ellipse given to find the value of k. That comes out to become 16. I hope you have understood this question. We'll meet again tomorrow with the next question. Till then, you can like, share, and subscribe if you are finding this helpful. Thank you.